From the perspective of a system growing from an idea into mass production, the story of Tesla Optimus is not only about humanoid hardware capable of walking, grasping, and working, but also about a decisive evolution in battery technology and algorithms. Elon Musk often talks about the learning curve over time, and for Tesla Optimus that curve passes through three layers: electromechanical form, artificial intelligence, and the energy platform. The journey from 18,650 cells to 2,170 and then to 4,680 is not a simple shell swap. It is how Tesla integrates mechanics, electronics, thermal management, and software to gain every additional minute of truly useful work per pound. So how has Tesla cooked this up? Where does Tesla Optimus's energy come from? Before we begin, please help us reach 15,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. The key point for Optimus is that the path electrons travel from the electrode to the casing is shortened, heat generation is more evenly distributed, and connection points are reduced, thereby limiting energy loss and thermal degradation when the robot exerts itself in peak power tasks such as lifting, tightening, or taking long strides. In practice, 4,680 technology has already been applied to the Cybertruck, enabling the vehicle to achieve a range of up to 500 miles with fast charging that takes only 15 to 20 minutes to reach 80% capacity. This provides owners with a longer, worry-free driving experience without the fear of running out of battery mid-journey, while also allowing Tesla to save on production costs by reducing the cost per kilowatt-hour by 56% compared to the previous generation, reaching about $55 to $60 per kilowatt-hour by 2025. When the robot first appeared publicly in its early stage, the engineering team described a battery pack integrated into its body with a voltage of around 52 volts and a capacity of about 2.3 kilowatt-hours. Optimus's computing platform uses the same family of self-driving computers as Tesla's vehicles, which means its capabilities in visual inference, occupancy mapping, and motion planning are directly inherited from the automotive domain. Placing a 2.3 kilowatt-hour pack into an AI platform already designed to run optimally at the edge with a strict energy budget means that the definition of a full workday is not a fixed number, but rather a range of operating times depending on the task profile. In contextual power consumption estimates, when the robot is idle, it draws around 100 watts, and when moving quickly it can reach about half a kilowatt. If the work shift is dominated by light movement, observation, and moderate load grasp and release tasks, the average power draw can hover around 200 to 300 watts. At this level, 2.3 kilowatt-hours translates to roughly 7 to 12 hours of operation between charges, with the 12-hour mark occurring when the task mix leans toward energy-saving activities. The key point is not to treat 12 hours as a hard promise, but as a point on a spectrum, achievable when hardware, software, and work organization models work together. In real-world application with Optimus Gen 3 in 2025, the 4,680 battery enables the robot to operate for up to 10 continuous hours and fully recharge in just 10 minutes, allowing owners, whether factories or households, to have a robotic assistant that works for extended periods without interruption, while Tesla saves up to 43% in component costs by integrating in-house produced cells. Looking back at the starting point, Tesla built its first generation of electric vehicles on 1865 zero cells. The abundant supply from the consumer electronics ecosystem and accumulated manufacturing experience made the 1865 zero a stable foundation for the company's early models. At the time, this configuration was far from obsolete, offering adequate energy density with nickel-cobalt-aluminum chemistry and a supply chain well hardened over time, delivering roughly 11 watt-hour per cell. However, as Tesla scaled up and sought to optimize cost per kilowatt-hour, it transitioned to the 2170 cell for the Model 3 and Model Y, with each 2170 storing around 17 to 20 watt-hour, about 30% more than 18,650. Enlarging the cell's geometry went hand in hand with refinements at the pack level, from module arrangement to cooling systems, and this accumulated know-how became the technical foundation for the next big leap. That leap came when Tesla unveiled the 4680 cell at the 2020 Battery Day event. It was not only about size but also a symbol of the philosophy of simplifying to increase margins. The tabless design reduces internal resistance, improves thermal management, allows higher current flow, and enables faster charging within the same volume. Specifically, the 4680 stores 5 times more energy, about 118 watt-hour per cell, with 6 times the power output compared to the 2170, while increasing energy density to 276 watt-hour per kilogram and extending electric vehicle range by 16%. The natural compatibility between the 4680 and a humanoid robot comes from the fact that the larger cell size allows the total number of cells to be reduced, requiring only about 1/5 as many as the 2170 to achieve the same capacity, significantly reducing connection points and weight, shortening wiring, decreasing the number of welds, and minimizing parasitic resistance. The tabless design shortens the current's path, improving heat distribution so that every joule released goes into actuators instead of being wasted as heat. In a limb system with multiple actuators, every millisecond of reduced latency and every percentage point of voltage drop avoided translates into smoother and more precise motion, while also reducing control noise that the AI must compensate for. The structural pack architecture turns the battery block into a load-bearing component, cutting down on non-functional materials and mass. A lighter Optimus by several kilograms will have lower locomotion costs both mechanically and energetically, while also improving safety when interacting closely with humans in confined spaces. In practical application, this gives owners a safer robot experience with reduced weight and higher rigidity, while allowing Tesla to save 69% in production capital investment thanks to the dry electrode process, which reduces manufacturing space and energy usage by up to tenfold. From an AI perspective, every working hour of Optimus is the result of 3 layers of optimization. At the perception layer, vision networks and occupancy maps learn to see just enough so as not to waste computation on irrelevant details. At the planning and control layer, algorithms optimize trajectories, reduce vibration, and choose stable static poses so that foot and hand placements require the least possible energy. At the system layer, the robot applies event-driven inference scheduling, powering up heavy computation only when the context demands it, while switching to energy-saving modes during steady phases. This is the same energy-saving philosophy honed in Tesla's self-driving vehicles, now translated to 2 legs and 2 arms. Because Optimus uses the same family of computers as Tesla cars, every optimization in latency, bandwidth, caching, power management, and thermal control can be transferred almost directly. How much will Tesla Optimus' latest price? During X Takeover event, Elon Musk unveiled a transformative vision for Tesla's Optimus Gen 3 humanoid robot, emphasizing its potential to revolutionize healthcare by supporting nurses with physically demanding and hazardous tasks. Engineered to operate continuously, Optimus Gen 3 could alleviate the strain of a global nursing shortage, paving the way for a future where robotic assistants enhance human care in hospitals and clinics. This article explores the robot's capabilities, challenges, economic impact, and adoption timeline, supported by the latest data and expert insights. Optimus Gen 3, powered by xAI's Grok 4 artificial intelligence, is designed for healthcare environments. Its real-time health monitoring system processes over 12 million medical data points in under 2.5 seconds, allowing swift adjustments to patient care protocols. The robot assists with patient mobility, leveraging a 50-pound carrying capacity and a 6-mile-per-hour walking speed to lift and reposition patients, potentially reducing nurse injuries, which affect 35% of healthcare workers annually. Its hands, equipped with 22 degrees of freedom and fingertip sensors with 0.08 millimeter sensitivity, enable precise tasks like wound dressing, potentially cutting infection rates by 22%. Optimus streamlines administrative tasks such as vital sign monitoring and documentation, saving nurses 2.5 to 3.5 hours per shift and boosting hospital efficiency by 18%. In high-risk settings like infectious disease wards, it minimizes staff exposure to pathogens. Demonstrations at the Tesla diner showcased its finesse, handling fragile objects with a 99% success rate, supported by 14 high-resolution cameras and 40 precision sensors, ensuring 97.5% collision avoidance in crowded environments. The global nursing shortage, at 5.8 million in 2023 and projected to decrease to 4.1 million by 2030, poses a significant challenge, particularly in low- and middle-income countries where 78% of the deficit is concentrated. Optimus Gen 3 could mitigate this crisis by reducing nurse burnout, which affects 45% of nurses globally, potentially lowering rates by 15 to 20%. Its continuous operation could increase hospital throughput by 20% in understaffed facilities. In high-risk environments, Optimus could reduce healthcare worker infections, which reached 15% during the 2020 to 2022 pandemic, by handling hazardous tasks. Technologically, Optimus Gen 3 stands 5 feet 9 inches tall and weighs 130 pounds. It carries 50 pounds, deadlifts 160 pounds, and walks at 6 miles per hour. Its hands, with 22 degrees of freedom and 0.08 millimeter sensor sensitivity, achieve a precision error rate of 0.4%, ideal for medical tasks. The Grok 4 AI processes data rapidly, and its 2.5 kilowatt-hour battery supports 22 hours of operation. With 14 cameras and 40 sensors, it navigates with 97.5% accuracy. Integrating Optimus into healthcare presents challenges. Cybersecurity risks, which impacted 44% of healthcare organizations in 2024, require software error rates below 0.008%. The robot's lack of emotional intelligence is a concern, with 70% of patients preferring human interaction for emotional care. Regulatory compliance with standards met by only 28% of robotic systems is critical. Additionally, 27% of nurses fear job displacement. Production delays, driven by a 10% overheating rate in joints and battery limitations, have pushed full production to the second quarter of 2026, with only 400 units built against a 6,000-unit target. Elon Musk projects Optimus Gen 3 pricing at $48,000 to $68,000 in 2026, reflecting $1.5 billion. Mass production by 2028 could lower costs to $18,000 to $28,000, comparable to a Tesla Model 3. Early adopters like Amazon and FedEx may pay a premium for its 96% task automation rate. In healthcare, Optimus could save $120,000 per unit annually by reducing overtime and improving efficiency by 22%. A rental program, priced at $150 to $600 per month, will enhance accessibility. Tesla plans to deploy 1,200 units in its factories in 2025, improving efficiency by 12%. By 2026, Optimus will be offered to external customers in healthcare and logistics, addressing 25% labor shortages. By 2030, Tesla aims to produce 1.2 million units annually, capturing 6% of the $220 billion robotics market. A 14% failure rate in dexterity tests has delayed progress. Experts are divided, with 62% praising Tesla's innovation, but 38% questioning its healthcare applicability compared to systems like Da Vinci, used in 1.5 million surgeries annually. Public sentiment shows 55% of patients are open to robotic assistance for physical tasks, but skeptical about emotional care. Achieving a 70% trust rate is critical for adoption. Optimus Gen 3 holds immense potential to transform healthcare by addressing the nursing shortage and enhancing efficiency in high-risk settings. Its advanced AI and dexterity are promising, but cybersecurity, emotional limitations, and production delays pose challenges. With strategic pricing and a rental program, Tesla aims to make Optimus accessible, but earning public trust through rigorous testing and transparency is essential. In a recent announcement, Tesla revealed that a functional prototype of its Optimus Gen 3 humanoid robot is expected to be completed within the next 3 months, with full-scale production slated to commence early next year. This timeline underscores Tesla's commitment to accelerating the development of its advanced humanoid robot, aiming to expand its applications across sectors like healthcare, manufacturing, and services. The concept of degrees of freedom refers to the number of independent movements a robot can perform. For instance, a robotic arm might rotate, bend, or move vertically, with each action counting as a degree of freedom. Through an optimized design, Tesla has incorporated additional joints, motors, and cutting-edge sensors into Optimus Gen 3, enhancing its agility and enabling it to tackle more intricate tasks. These improvements allow the robot to execute highly precise movements, from handling delicate objects to performing complex operations with finesse. Currently, Optimus version 2.5 is capable of executing approximately 1,500 basic tasks, such as gently holding an egg without breaking it. Optimus Gen 3, however, is projected to double this capacity, potentially reaching 3,500 tasks. The increased degrees of freedom paired with advanced AI algorithms from Grok 4 make Optimus Gen 3 more versatile and precise, opening the door to a wider range of practical applications. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.